Hey everyone, welcome back. This is Maddie. In this video, we'll be seeing the time complexity analysis of if and while. We'll start with while loops first, and then at the end, we'll be seeing the if block. Let me just take our first example for while loop. We'll be having some statements inside while loop. After executing all the statements, we'll be incrementing I. Close the loop. Now let's analyze the time complexity of this while loop. Isn't this while loop same as our normal for loop? Let me just write that for loop. Starts from 0. This we are done. And the condition check. Even this part we are handling it in for loop. And update statements. Even this is getting done in for loop. If the condition holds good, then the statements gets executed. Isn't this while loop same as this for loop? And we know the time complexity of this for loop is nothing but order of n. If you have not watched my previous videos, please do watch it and come back to know the time complexity of the normal for loop. This initialization takes 1 unit of time. This condition is checked n plus 1 time. And these statements again gets executed n times. Even update statement gets executed n times. After adding all these things, 1 plus n plus 1 plus n plus n. This will be 3n plus 2. As we know, we'll be considering the dominating term, and in the dominating term, we'll be ignoring the constant, and we'll consider n as our time complexity, which is the highest degree. Time complexity of above while loop is order of n. Our second example is 1 while a is less than b. Will execute some statements. Will increment a by multiples of 2. As soon as you see this update statement, you should remember of something, right? Let us see what is that something. I'll dry run this while loop so that you can understand it easily. We'll take a and update statement. For this dry run, I'll just consider b as 10. A is starting from 1. Will start from 1. Is 1 less than 10? Yes. The statements inside while loop gets executed, and after executing the statements, update statement will run, which will update a value from 1 to 2. This gets updated to 2. Now a is 2. Is 2 less than 10? Yes. So statements gets executed, and then update statement will execute, which will update the value of a from 2 to 4. Now a is 4. Is 4 less than 10? Yes. Update statement get executed, which will update value of 4 to 8. Now a value is 8. Is 8 less than 10? Yes. So update statement gets executed, which will update this value to 16. Now a is 16. Is 16 less than 10? No. While loop breaks here. Why is our loop breaking? Since we know the value of b, which is 10, and the condition says that if the value of a is less than b, then executes the statements inside while loop and then the update statement. In this case, 16 is greater than 10, so the while loop breaks. And this break is happening since we know the value of b. But what if the value of b is unknown? Until when our loop runs? To find out that, let us observe the pattern in update statement. All these numbers are multiples of 2. Can't we just write them in this way? 2 to the power 1, 2 to the power 2, 2 raised to 3, 2 raised to 4, and our for loop runs until 2 raised to power something. We need to find out this something. Let us consider this as k for now. So our loop runs until a is 2 raised to power k, and k is unknown for now. Loop runs until a equals 2 to the power k. To find out this k, we need to check when is our loop stopping. When will our loop stops? Our loop stops when a is greater than or equal to b. It executes until a is less than b. So it stops as soon as it becomes equals or greater than b. Loop stops when a is greater than or equal to b. We know the value of a, which is 2k. We can just substitute that value here. 2 to the power k is greater than or equal to b. To find this k, which is stuck in exponent, we need to bring that down. To bring that down, we need to apply log on both the sides. Log 2 on both sides. Log 2 of 2k is greater than or equal to log 2 of b. According to log general rule, this becomes k. Let us see the general rule first. According to log general rule, which is nothing but log b into b to the power x is nothing but x. If we apply this formula here, we'll end up with k is greater than or equal to log 2b. K is greater than or equal to log 2b. We got the value of k, which is nothing but log 2 of b, and after ignoring the constant 2, we'll end up with time complexity of our while loop, which is nothing but big O of log b, meaning our while loop runs log of b times. I hope this example is clear. Let us move on to our next example. We are starting I from n while I is greater than 1. We'll execute some statements. After executing, we'll update I by 2. As soon as you see this update statement, you should again remember something. Let us see what is that something. I'll try run this while loop with I and update statement. For this dry run, I'll just consider n as 20. We are starting I from n, which is 20 in this case. Is 20 greater than 1? Yes. Statements will be executed and then update statement. which will update I value by dividing it by 2. 20 by 2, which is nothing but 10. Now I is 10. Is 10 greater than 1? Yes. Statements will be executed, and then update statement, which will divide the current value of I by 2, which will be 5. Now I value is 5. 5 is greater than 1. So update statement will update the value of I by dividing by 2, which will be 2.5. Now I value is 2.5. 2.5 is greater than 1. So divide it by 2, which will be 1.25. Now I value is 1.25. 1.25 is greater than 1. So divide it by 2, which becomes 0.75. Now I value is 0.75. Is 0.75 greater than 1? No, our while loop breaks here. Why is our loop breaking? Because we know the value of n, which is 20. That's the reason it's breaking the loop. What if we don't know the value of n? Until when our loop runs? To find out that, we need to find the pattern here in the update statements. All these values are getting divided by 2 in every iteration. Can't we just write these values as n by 2 and this as n by 4? This will take n by 8, n by 16, n by 32. Yes, all the values holds good. Again, we can generalize these values to n by 2 to the power 1. Since all the values are multiples of 2, we can write these values with power of 2. 2 cube, 2 raised to 4, n by 2 raised to 5. Since we don't know the value of n, in this case, our loop runs until n by 2 to the power something. We can consider this something as k, and k is unknown for now. We need to find the k. Let me just write down that. Loop runs until I equals n by 2 raised to k. To find this k, we need to check when is our loop stopping. Our loop stops when I is less than or equal to 1. It runs until the value of I is greater than 1, and it stops as soon as I value becomes 1 or less than 1. This will lead to finding k. Loop stops when I is less than or equal to 1. We know the value of I. We can directly substitute that. N by 2 raised to k is less than or equal to 1. We can bring this 2 raised to k on the right hand side. N is less than or equal to 2 raised to k. To bring down this exponent, we can apply log 2 on both the sides. Log 2 of n is less than log 2 of 2 raised to k. Again, the same log general rule. We can apply that up here. Log 2n is less than or equal to k. We got the value of k, which is nothing but k is greater than log 2n. After ignoring the constant 2, we'll end up with the time complexity of our above while loop. Therefore, the time complexity of above while loop is nothing but big O of log n, meaning our while loop runs log of n times. I hope all these concepts are clear. Let us take our next example. I equals 0, k equals 0, while k is less than n. Execute below statements. Update k by adding I to current k. Update I value after each iteration. Even we have covered these kind of update statements in our for loop. Nothing is new in this video if you have watched my previous videos. Let us dry run this while loop. We'll have the value of I here and then update statement. Update statement k. I'm just considering this thing. For this dry run, I'll just consider n value as 15. We are starting loop from I0 and K0. I need one more column here, I and K. I is starting from 0 and K is also starting from 0. And the condition will check whether K is less than n. Yes, 0 is less than 15. So the statements inside while loop gets executed, and then the update statement will be executed, which will update the value of k by taking the current value of k and adding the I value to it. We can just write this as k equals current k 0 plus I, which is 0. And then I value gets incremented to 1 and k value remains the same, which is 0. Now the condition is checked. 0 less than 15, yes. So update k, take current value of k and add I to it. Now I gets incremented to 2. 2. Current value of k is 1. 1 is less than 15. So k value gets updated by taking the current value of k and adding I to it. Even we can consider these as well. 0 plus 1. I value gets incremented to 3. K value is 3. 3 less than 15. So k value gets updated. Take current k, 0 plus 1 plus 2 plus 3, add I to it. Now I value gets incremented to 4. K value is nothing but 3 plus 3, 6. 6 is less than 15. So update k value, take current value of k and add I to it. I value gets incremented to 5. K value is 6 plus 4, 10. 10 is less than 15. So update k value, take current value of k, which is nothing but 0, 1, 2, 3, 4, and I add I value. I value gets incremented to 6. Now k value is 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. Is 15 less than 15? No. For loop breaks here. And the statements inside will not be executed. Now the keynote to think is, why is our while loop breaking? Since we know the value of n, we are able to loop all the cases. But what if we don't know the value of n? Until when our while loop runs? If we solve this, we'll get the time complexity of this while loop. To find that, let us observe the pattern in update statement. What update statement is doing is, it is taking the previous value of k and adding the current I value to it. In that case, can't we just consider this as 1 plus 2 plus 3 plus 4 plus 5 plus m, and this m is unknown to us for now. We need to find out the value of m. To find out the value of m, we need to check when is our loop stopping. Before that, let me just write down this here. Loop runs until k equals 0 plus 1 plus 2 plus 3 plus until m. To find out this m, we need a lead. What is that lead? We need to check when is our loop stopping. Our loop stops as soon as k value is greater than or equal to n. It runs until k is less than n, and it stops when k becomes either equal to n or greater than n. Loop stops when k is greater than or equal to n. We know the value of k, which is nothing but sum of n natural numbers. 0 plus 1 plus 2 plus 3 plus until m greater than or equal to n. We can just replace this with sum of n natural numbers, which is nothing but m into m plus 1 by 2 is greater than or equal to n. To get rid of this denominator, we can multiply both the sides by 2. Multiply both sides by 2 to remove the denominator. 2 into m plus 1 by 2 greater than or equal to 2n. These 2's get cancelled. We'll have m into m plus 1 is greater than or equal to 2n. We can multiply m here, which becomes m square plus m is greater than or equal to 2n. As we have discussed in our previous video, in terms of time complexity, we will always ignore the lesser values and will only consider the dominating term in the expression. The dominating term here is m square. So we'll just consider m square greater than or equal to 2n. To remove the exponent, we can apply square root on both the sides. If you have not understood this step, please do watch my previous video. I have clearly explained this with an example. We'll apply root on both the sides. M square greater than or equal to root 2n. This gets cancelled. M is greater than or equal to root 2n. We can split these terms. M is greater than or equal to root 2 into root n. Again, same concept. We'll be ignoring the lesser values and we'll only consider the dominating terms, which will be having m of root n. Even this value is considered as constant. Constant times are ignored in terms of time complexity. Therefore, we got to know the value of m, which is nothing but root n. Therefore, the time complexity of above while loop is nothing but big O of root n. I hope all these 4 examples are clear and nothing is new in this video if you have watched my previous video. Both for and while loop are same. Even the time complexity will also remain the same. Let us see the time complexity of if block now. We'll just take the example. We'll just write a simple algorithm which has if block. We'll have a method here by name test. We'll begin the method. This is where if condition comes. If n is greater than 5, execute some statements. Else, we'll have a for loop in the else block. I is less than n, I plus plus. Execute some statements, some sysounds or something. We'll end the for loop and else block. And at the end, the function is ended. Now, We all know in time complexity, the simple statements takes 1 unit of time, right? This is just a comparison and it takes only 1 unit of time. And the time complexity of these statements depends on the logic. Since we are considering only the time complexity of if block here, the condition will take only 1 unit of time. We'll just ignore the time complexity of these statements as these statements are unknown to us for now. If n is less than 5, else block will be executed. The time complexity of else block is nothing but a for loop of n times, and we all know this executes 1 unit of time, this gets executed n plus 1 time, and this executes n time 1, n plus 1, and n. And the statements inside for loop will also take n unit of time. Therefore, the time complexity of this for loop is nothing but n unit of time. Now for this algorithm, we have two time complexities. Which one to consider? We can consider both of them by mentioning this way. Algorithm takes minimum of 1 unit of time and maximum of n unit of time. Since we don't know the value of n, we can mention the algorithm takes minimum of 1 unit of time and maximum of n unit of time. And the time complexity of if block depends on the condition and the code block inside it. I hope this part is clear. That's it for this video. Just to reiterate, we have seen all the types of time functions for while loop, whatever we have seen for for loop. We have seen big O of n, big O of log n, big O of log n, big O of root n, and the time complexity of if block. In the next upcoming video, we'll be seeing the types of time functions and we'll try to compare those types of time functions. Thank you all for watching. See you in the next one.